In this video, we will learn about identification of gases. The first gas that we will study is chlorine, written as Cl2. Cl2 can be formed when concentrated hydrochloric acid undergo decomposition in the presence of oxidizing agent. You can take MnO2, Pb3O4 or PbO2 as an oxidizing agent and you will get Cl2 as a product. The second method is with the help of bleaching powder. The chemical formula for bleaching powder is CaOCl2. This H positive shows that bleaching powder is undergoing reaction with dilute acids and we are getting Cl2 as a product. The points of identification of chlorine gas are that it is greenish yellow gas and has a very pungent smell. It also turns blue litmus paper to red, showing its acidic behavior. It can turn colored matter to colorless. This is due to the formation of this nascent oxygen. This nascent oxygen is formed when chlorine reacts with H2O and we get HCl and HOCl. This HOCl then undergoes decomposition to give HCl and nascent oxygen. The last point of identification is that whenever starch iodine paper reacts with chlorine, it results in the formation of blue-black color. This blue-black color is formed due to iodine. Initially, you have iodide ions, and these iodide ions get oxidized to give iodine. The second gas that we have to study is hydrogen chloride gas. This hydrogen chloride gas can be obtained when metal fluoride react with concentrated H2SO4 and you get metal sulfate and hydrogen chloride. The points of identification are hydrogen chloride is actually a colorless and pungent gas. It turns blue litmus to red, which shows its acidic nature. And when you will bring ammonia near the HCl, you will always observe dense fumes due to the formation of ammonium chloride. The last point of identification is that HCl on reaction with AgNO3, that is silver nitrate solution, will result in the formation of AgCl as a precipitate and it will turn curdy. The third gas that we have to study is hydrogen sulfide, written as H2S. Metals do react with metal sulfide react with H2SO4, that is diluted H2SO4, and give metal sulfate and H2S, that is hydrogen sulfide. The points of identification are it is a colorless gas and has smell of rotten eggs. It also turns moist lead acetate paper to black. Now, this black color is obtained due to the formation of lead sulfide. The last point of identification is that we know that KMNO4 is initially pink colored, but when you acidify it with H2SO4 and it undergoes reaction with H2S, it will result in the colorless solution. The fourth gas that we have to study is nitrogen dioxide, written as NO2. Nitrogen dioxide can be produced by heating heavy metals, but as an exception, you cannot take sodium and potassium because they do not result in the formation of NO2. Therefore, we have taken copper and lead. The points of identification are that this is reddish brown gas and it has a very irritating smell. It do turn moist blue litmus paper to red, shows its acidic nature. On reaction with potassium iodide, here you can see that NO2 when reacts with potassium iodide, you get KNO2 and iodine is liberated. The fifth gas that we have to study is ammonia, written as NH3. Now, ammonia can be obtained when ammonium salt, this is the ammonium salt, reacts with alkali and we get a salt, water, and ammonia gas. The points of identification are it is a colorless gas and it has a very pungent smell. Here you can see that it turns red litmus to blue. This shows that ammonia is actually basic in nature. When you will bring a glass rod that is actually dipped in HCl near ammonia, you will find dense fumes due to the formation of NH4Cl. Also, pale blue precipitate is formed when copper sulfate solution reacts with NH4OH. The last point of identification is that with Neffler's reagent, whenever you will see the reaction of ammonia with Neffler's reagent, you will get a brown color as a product. I hope this topic is clear to you. Thank you.